You take a bite, and your mouth feels like it's on fire. Your face warms up. Your nose starts running. Your heart beats a little faster. It's not just spicy. Your whole body seems to react. And naturally, a question comes up. Is this actually hurting something inside me? Because sometimes the heat doesn't stop in your mouth. It moves down your throat. It can sit in your chest. Your stomach might remind you about it later. So what's really happening inside your body when you eat spicy food? Are your organs being irritated or damaged? Or is this intense burning sensation just your nervous system doing exactly what it's designed to do? Once you understand the science behind it, the experience feels very different. You're not actually being burned. That intense heat you feel isn't temperature at all. It comes from a chemical called capsaicin, the compound found in chili peppers that makes them spicy. And here's where it gets interesting. Capsaicin doesn't damage your mouth. It activates the same nerve sensors that normally respond to real heat. These sensors are called TRPV1 receptors. They're the ones that fire when you touch something hot. So when capsaicin binds to them, your brain receives the same signal it would get from actual heat, even though your tissues aren't burning. There's no rise in temperature, just stimulated nerves. Research shows this reaction is neurological, a signal being triggered, not tissue being destroyed. That's why you sweat, why your face turns red, why your heart rate may tick up slightly. Your body thinks it needs to cool down from heat that isn't really there. So the burning sensation is real, but it's a signal, not an injury. Once that heat leaves your mouth, it travels down your throat and into your esophagus, the tube that carries food to your stomach. And this is where some people feel that familiar chest burn. Capsaicin activates the same heat-sensitive nerve receptors in the lining of the esophagus. So your brain reads the signal the same way it reads heartburn. But here's something important. Spicy food doesn't automatically cause acid reflux. Research in gastroenterology shows capsaicin doesn't increase stomach acid in healthy people. What it can do is irritate tissue that's already sensitive. So if someone has acid reflux or GERD, spicy food can make symptoms feel stronger. Not because it's creating new damage, but because it's amplifying what's already there. That's why one person can eat extremely spicy food with no issue, while another feels burning within minutes. It often comes down to one small structure, the lower esophageal sphincter, the valve that keeps stomach acid from moving upward. If that valve is weak, spice can make symptoms louder. If it's working properly, your body usually handles the signal without trouble. Which raises the next question. What happens when that spice finally reaches your stomach?
This is where most people get worried. Your stomach. For years, many people believed spicy food causes ulcers, but modern medical research shows that's not how ulcers usually form. Most stomach ulcers are caused by a bacterial infection called Helicobacter pylori, or by long-term use of certain painkillers like NSAIDs, not by chili peppers. Studies supported by the National Institutes of Health show capsaicin does not directly damage the stomach lining in healthy individuals. Your stomach is built to handle acid strong enough to break down food. To protect itself, it produces a thick layer of mucus that acts like a shield between the acid and the tissue underneath. And here's something surprising. In moderate amounts, capsaicin may actually stimulate protective responses in the stomach, including increased mucus production. But there's an important nuance. If someone already has gastritis, an ulcer, or an inflamed stomach lining, spicy food can irritate that sensitive tissue and make symptoms feel worse. So the spice isn't creating the injury, it's revealing one that's already there. In a healthy stomach, it usually passes through without harm. In an irritated one, it can feel much more intense.
After your stomach finishes its work, the spice continues into your small intestine and colon. And this is where some people really notice it.
Capsaicin activates heat-sensitive nerve receptors all along the digestive tract, not just in your mouth. When those nerves fire, your intestines can start moving faster. In medical terms, that's increased motility. And that's why some people feel urgency or even diarrhea after a very spicy meal. Not because the intestines are damaged, but because they're reacting more quickly than usual. People with irritable bowel syndrome, or IBS, often have more sensitive nerve endings in the gut, so spice can trigger stronger cramping, discomfort, or loose stools in them. But in otherwise healthy individuals, the digestive system usually adapts. In fact, regular exposure to capsaicin may reduce gut sensitivity over time. So once again, it's not automatic harm, it's stimulation. The sensation can be intense, but it's your nervous system reacting, not your intestines being burned.
When you eat something very spicy, and your face flushes, your heart beats faster, and you start sweating, that's not random. Capsaicin briefly activates the part of your nervous system responsible for fight or flight. Your blood vessels widen slightly, circulation increases, your body produces a bit more heat. This process is called thermogenesis. Research supported by the National Institutes of Health shows capsaicin can slightly increase energy expenditure and fat oxidation in the short term. In simple terms, your body may burn a few extra calories while responding to the spice. There's also interesting data from populations where chili consumption is common, suggesting possible links to lower rates of certain cardiovascular risks. But the effect is modest. Spicy food isn't a fat loss shortcut. It may gently stimulate metabolism, but it won't override overall diet or lifestyle. So when your heart beats a little faster after a spicy meal, it's usually a temporary nervous system response, not heart damage, unless someone already has rhythm disorders or severe reflux, in which case symptoms can feel more noticeable. For most healthy people, it's stimulation, not injury.
For most healthy people, spicy food doesn't damage your organs. What you're feeling is nerve stimulation, not tissue being burned. Your stomach has protective mechanisms. Your digestive system adapts. And in moderation, many people tolerate spice without harm. Some observational studies have even found associations between regular chili consumption and certain metabolic or cardiovascular benefits. But context matters. If you already deal with acid reflux, chronic heartburn, gastritis, ulcers, or irritable bowel syndrome, spicy food can make symptoms feel worse, not because it's creating new damage, but because it irritates tissue that's already sensitive. And if you ever experience severe chest pain, persistent stomach pain, or unusual digestive distress after eating spicy food, that's worth discussing with a doctor. Spice is stimulation, and stimulation feels stronger in systems that are already inflamed. So the better question isn't, is spicy food dangerous? It's, how sensitive is my system right now? For many people, moderation works well. For more sensitive systems, less is often better. Your body usually gives you clear feedback, if you pay attention. For more health tips, subscribe to the channel. So, the next time your mouth feels like it's on fire, remember, you're not being burned. You're experiencing a nerve signal, a temporary activation, a designed response. For most healthy people, spicy food is stimulation, not damage. And once you understand what's actually happening inside your body, the sensation feels very different, because clarity replaces fear. Now, here's something worth thinking about. Spice stimulates your system. Alcohol does something very different. Regular drinking affects your liver, your heart, and even your brain, not through nerve illusion, but through real biochemical changes. And the way those changes build over time is far less obvious than most people assume. If this surprised you, the alcohol episode might change how you understand your next drink.